So a polynomial is an expression that's written as the sum or difference of numbers that have the following features. They have a coefficient. And now again, this continues. It can continue depending on how high your power is. Okay. As far as the coefficients are concerned, these coefficients can be any real number. Okay, so the multiplier in front of your variable term can be any real number. It's normally going to be an integer, okay, but it is possible that it has any other of the real number forms. So it can even be a square root of something, or a fraction, or a decimal. Okay, then you have your variable terms. Okay, and actually this a value, more specifically, is referred to as the leading coefficient. Okay, the x's are just your variables. Okay, so they can represent one letter. It could be multiple letters as well. And then the powers to these exponents are represented by this n value. Whatever your first n value is, that's going to refer to the degree of your polynomial. Okay, and so whatever the degree is, you notice that each consecutive term will decrease by 1. Okay, now if they've completely disappeared, then that means the coefficient of it was 0, so it's not written there. But you start with your highest power, and then you write it in decreasing order from that. And you're always going to end with some final letter. Okay, I'm just going to call it z. Okay, and that final letter, if it has no, notice in this case it has no variable, no x to any power, it's just going to be your constant. There's no variable to it. It is referred to as a coefficient as well, but it stops right there. So there's a couple properties that identify polynomials. The powers are always going to be whole numbers. Okay, so the powers will range from 0 to infinity, but they're only going to be positive numbers. If you have anything with a fraction or a negative number as the power, it's not considered a polynomial. Okay, so if I ask you to identify the following, is this considered a polynomial? Why not? The reason is the power a whole number? No, it's a fraction, so it's not considered a polynomial. And what if I gave you something that looked like this? Does this fit the form of a polynomial? Yeah, it's just the constant, right? Nothing else exists. It's just the constant. So this is a polynomial. And again, it's just referred to as the constant, or a constant. And what if I gave you something like this? Is this a polynomial? Yes. You look at the powers of x, all the powers of x whole numbers. Yeah. And then that's all you really have to test for. Again, the fact that your constant is an irrational number is still fine. It still fits with this. Okay? All you have to do is make sure that there's no variable in the denominator of a fraction, okay, which would give it a negative power. Okay? Now, if I ask you to write this in the standard form of a polynomial, how would you have to move these around? What's the highest power? X to the first. So you'd have to write that term first, a negative x, and then plus square root 5. So this would be the standard form. Okay, when you're looking at that, your constants are really just x to the 0. Okay? But x to the 0 is what? Anything to the 0 is? 1. So z times, or your constant times 1 is just the constant. So you don't even write that down. That's why I wrote it in that light colored yeah, it's light. But it's because you don't have to actually represent it, but that's kind of what it means. You reduce it all the way down from highest power to lowest. Okay, when you're dealing with each individual term of a polynomial, okay, each of these is considered an individual term. Anything that's separated by a plus, okay, is an individual term. So when you look down at this bottom expression that is a polynomial, how many terms does this polynomial have? 2, right? There's 2 items that are separated by a plus. Here's one, and here's the second. Okay, and so when you identify those, you can name a polynomial by the number of terms. One term is called a monomial. 2 terms is a binomial. If you had 3 terms, it would be a trinomial. And then beyond that, it's pretty much just referred to as a polynomial. But the monomial, binomial, trinomial have specific names. Okay. You can also, when you're looking at these, let's see, when you're identifying the terms of a polynomial, any negative signs are contained within the individual terms. So if I gave you an expression that looked like this, all right, so in looking at this, is this a polynomial? Basically testing, are all the powers of our x's whole numbers? Yeah. And is it written in standard form? Okay, so what would be the standard form for this? So the highest power first, which is, okay, followed by, all right, so when you write it in standard form, you write it from the highest power to lowest power. Okay, as far as each individual power, or each individual term, when you look at its power, you can refer to the degree of each term. The degree of each term is just its power. Or if it has multiple variables, it's the sum of powers. So what would be the degree of this term? It's a second degree term. What would be the degree of this term? The degree is 5. It's just its power. What would be the degree of this term? 1, or it's a first degree term. What about this one? 3. And then finally, what about this constant? 0. Okay, so a constant has a degree of 0. Okay? Now, you can also refer to the degree of the polynomial. And when you find the degree of a polynomial, it's whatever the degree of the leading term. When it's written in standard form. Okay, so what would be the degree of this polynomial here in the top? It's 5, right? When you write it in standard form, what's the highest degree? That is the degree of the polynomial. Okay, the final thing, in talking about the degree of terms, I'd mentioned or sum of powers. If that means if you had something like this, if you have multiple powers and you have to identify the degree, you're simply going to add the term. So what would be the degree of this term? Add the powers, you get 1 plus 2 is 3. So this is a third degree term. What about this one? A second degree, or a degree of 2. And what about this one? Again, a degree of 0. All right, questions on that?